Yeah, Bismillahirrahmanirrahim. We start our lecture today with chapter 5. And then please be remember after Hari Raya on week 8, we are going to do the midterm test. Basically 30 questions, 1 hour. Okay, that one is the objective question. Do you want the subjective question? Objective or subjective? Okay, objective. Okay, now we look for the first order logic. First order logic is also known as a predicate logic. It is a quantificational logic. You need to quantify the amount. And then first order logic calculus, it is a collection of formal system used in mathematics, philosophy, linguistics, and computer sciences. Okay, this one is first order logic. For example, we have field x. Okay, we define act as a field. Okay, and then it is a symbolized reasoning for subject and also predicate, also known as predicate logic, quantificational logic, and first order predicate calculus. Okay, for the content, it is more on a representation, okay, symbolic. Okay, and then we go by the syntax and semantic of first order logic. Using first order logic and knowledge engineering on first order logic. This one is just a review. Okay, for definition, basically also known as predicate logic, quantification logic, and first order logic, predicate calculus is a collection of formal system used in mathematics, philosophy, linguistics, and computer sciences. And then the first order logic uses quantified variable over non-logical object and allows the use of sentences that contain the variables. Okay, and then for example, we have Socrates is a man. Uh, One can have expression in the form of there exists X, such that X is Socrates and X is a man, whereby the there exists is a quantifier, while X is a variable. X is a variable that define the domain of discourse over which the quantified variable range. Okay, we have a variable. Okay, and then finitely, many predicate defined on domain and the set of axiom believed to hold some theories. Some theories, and then we have this distinguishes it from propositional logic, which does not use quantifier or relationships. In the sense that propositional logic is the foundation of first order logic. Okay, do you have any question? Ada soalan ke? Yeah, professional logic normally when you say the professional logic, it is a statement that can either true or false. It is a statement either true or false. Okay, and then it must be one or the other and cannot be both. It must be either true or false. Okay, for example, for professional logic, Okay. They say if the moon is made of cheese, then basketball around. Okay, and if the spider walk with a limb. Okay, this one exactly the same. They are both implication statement of the form P implies Q and also P implies Q. We have both seen P implies Q. Okay. Okay, then first order logic, aka first order predicate calculus, aka first order predicate logic is a standard formalization for axiom. Okay, what is axiom? What is axiom? Okay, axiom is a statement that accepted true as a basic for argument or inference. Okay. Axiom normally we go by the argument or inferences. Okay, more powerful than propositional Boolean logic. It have a greater expressive power than propositional logic. We are no longer needed a spread rule for each square to see either square are busy or pits. And it allows for facts, object, and relations. In programming terms, it will allow the classes, function, and variables. Okay, we have pros and cons of propositional logic. Basically, for the uh, propositional logic used to planning, problem solving, for the normally for decision making. And then the propositional logic is declarative. Declarative means it can be declared in a certain domain of problems. And then the pieces of syntax corresponded to the facts. Number two, it is a plus sign is the pros. Professional logic allows for partial disjunctive negated information, unlike most data structures and databases. And then propositional logic is compositional, meaning of B11 and P12 is derived from the meaning of B11 and P12. P-compositional mean okay. The principle meaning a complex expression is determined by the meaning of a constituent expression and the rule used to combine them. Okay, it's compositional. Okay, we have a rule here. B11 and P12. They have two rules here, one and two. Okay, then Meaning of propositional logic is context independent, unlike the natural language, which are the meaning depend on the context. Okay, for propositional logic, it's not depend on the context; it depend on the semantics. And then the drawbacks. The drawbacks is propositional logic has very limited expressive power, unlike the natural language, because it lack of syntax. Okay, and then first order logic can be assumed in three different types. First one is the objects. For example, we have people, houses, numbers, theories, colors is an object. And then we can also define first order logic as a relation. For example, we have rate, round, prime, bogus, okay, owns. And then also we can use as a functions. For example, we have father of, best friend, third quarter of, more than, more, one more than, beginning of, and so on. And then for logic in general, we have a language. We compare propositional logic, first order logic, temporal logic, probability theory, and fuzzy logic. And then for the ontological commitment, it is a relationship and concept and categories. It combine the concept and categories. For propositional logic, it is a facts. For first order logic, it's combination of facts, object, and relations. Same goes to temporal logic. Okay, but for the epistemological commitment, it is for the knowledge or reasoning. It is must be true or false or unknown. Okay, and then for the fuzzy logic, known for the interval values. Okay, we have a syntax of first order logic. Okay, we have constant. Okay, we have predicates that have properties of the subject. For example, brothers, less than, equal to. And then we have functions. We have variables. We have connectives. We have equality, and then we have quantifiers. Key component of first order logic for the terms. For example, we have constant. Example rate. Function of constant. Block one color is a color red. Okay, and then for the atomic sentence, is predicate that relating the object, which is no variable. For example, John is the brother of Richard, and then John mother married John father. Okay, this one is atomic sentence, which means that a simple sentence is the smallest linguistic entry that has true value. Okay, the atomic sentence, or we can call it as simple sentences that has true value. For example, we have Jack cook a dinner. He is intelligent. She brought the wine. Okay, this one is atomic sentences. And then we have a complex sentence. Complex sentence is formed by adding one or more subordinate. For this one, we combining the atomic sentences and logical connective. Okay, complex sentence is a sentence made up of smaller sentences based on the atomic and logical connective. For example, here we have a John as a brother of Richard, and John is not a brother. Uh, is not the brother, and then because John is the father. Okay. Okay. Another example. Sarah can swim, but she cannot dive. Okay. Okay. And then a complex sentence must be de- declarative. Must be declarative sentence. This one must be declarative. Declarative sentence. Okay. So far ada soalan ke? So far do you have any question? Irfan boleh ke? Ahmad Irfan? Sheila okay ke? Okay. Okay, then we look for the quantifiers. Quantifiers in the first order logic. Okay, for the quantifiers, uh, each quantifier defines a variable for duration for the following expression and indicates the truth of the expression. And then these are the symbols that permit to determine or identify the range of and also the scope of the variable in the logical expression. Okay, we have quantifier. We have a universal quantifier for all, and then we have an existential quantifier that exists, and then we also have connective predicate and variables. Okay, we have constant symbol, we have predicate symbol, and then we have function symbols. Okay, sentences are true with respect to the model and interpretation, and then model must be contain more than one object. It is based on the domain elements and the relation among them. Okay, quantifiers, identify, range and scope. Okay, for example, here we have a person, we have a person king, and then for the association we have brothers, and then for the king person must have a crown on the head, and then we have a left leg as the uh, function symbol. Okay, and then universal quantification, we must use the variable and sentences for the syntax, and then for all x, p is true in a model m if and only if p with the x being each possible object in the model. Okay, common mistake to avoid. Some of you might use the main connective with for all is disjunction. Okay, normally when you use the for all, we use the implication here as a symbol. Okay, and then existential quantification. Normally we use the variable and sentence. Okay, we use the disjunction or instantiation of PF because we are dealing with the domain of discourse. basically we identify as an object. Common mistake to avoid, uh, some of you using the implication as the main connective with the for sum. Okay, normally we use this one, this junction. Okay, for example, everyone likes McDonald. Okay, for all X, and then X likes McDonald. And then for someone likes McDonald, X like McDonald, and then we have X for some. And then we have properties of quantifier. Okay, this one also same. Okay, if you have for all Y is same with the for all Y, for all X. Okay, but this one is not the same. If you have for some X, for all Y is not the same with the for all Y, for some X. For example, there is a person who loves everyone in the world. Everyone in the world is loved by at least one person. Okay, this one is not the same. Okay, and then we have a nested quantifier. Nested mean we combine more than one quantifiers. Okay. Okay, example, not everyone likes McDonald. Okay, for all X like McDonald, you can use the negation, first one. And then you can also use this one for some X like McDonald's. Okay, no one like McDonald. Also same for this one and this one. Okay, this one is another example. All birds can fly. Okay, and then we we go by the predicates fly bird, and then for all X bird, as an X fly X. Okay, we define a predicate with a variable X, and then every man respect his parent. Okay, you can uh, choose a predicate respect xy, whereby the X is a man, Y as a parent. So every man for all X, man X uh, implies respect X, parent X, respect parent, whereby X is a man. Okay, for this one, some boys play cricket, and then the predicate play, and then we have X Y, and then we define X as a boy and Y as a game. Why we define Y as a game? Nurul Syafika ada jawapan ke? Why we go by the Y as a game, not the cricket? Nurul Syafika? Kenapa kita panggil dia game? Kita tak buat cricket. Hmm. Okay, because normally when you have instantiation, because in the predicate we selected the object, and then cricket is a game. Okay, and then for some X, boy X implies X play cricket. Okay, but here we generalize the object. Okay, not all students like both mathematics and sciences. Okay, a predicate like XY. Okay, okay, and then we have X as a student and Y as a subject. Okay, X as a student and Y as a subject, because we have mathematics and sciences. Okay, so Not all students like both mathematics and science. We can use for all X, student X implies subject math and sciences. Okay, and then we negate for all X students. Okay, X like mathematics and X like science. And then we use the disjunction here. Okay, boleh ke? Aiman Zulkifli boleh ke? Okay, please extract the predicate first. Okay, extract the predicate first, and then you do the. Okay, for this one, only one student fail in mathematics. You can extract the predicate as fail, x and y, and then x as a student, y as a subject. And then for some x, student x is a student, implies fail, x fail mathematics, and for all y, we use the negation here, x equal to y, and then we use the disjunction, student y implies uh, negate fail, x fail mathematics. Okay, we initialize x to y. Okay, because we want to have only one student fail in mathematics. Okay, this one is fun with sentences. Okay, this one is other comment about the quantification. This one is equality. Okay, this one is one post a word. I think we learn until here. Fun with sentences. Okay, so far, do you have any question? Okay, boleh faham ya? Dia ada okay, okay. Yeah, please do this exercise. There's a exercise. Every clause in Java. Okay. Aiman, Aiman Zakri, how to do that for the solution? Aiman, Aiman Zakri ada ke? Fatin, Fatin ada? Fatin Syafawani? Fatin ada? Eh, Nausila ada? Nausila? Ah, macam mana tu? Every student in the class has taken a course in Java. Macam mana nak buat? Apa dia? Okay, first you need to decide the domain. Domain. What is the main domain here? Okay, if domain U, normally we are using U, domain. If U is all student in this class, define the propositional function J x. Okay, we define J x. Okay, x has taken course in Java. Okay, then we denote for for all x. Okay, and J x. Okay, this one is first solution. Okay, second solution. Okay, but second, but if you is all people, also define a proportional solution function for Sx. Okay, we denoting Sx as x student in we can define as for all x. Okay, okay. Okay, please extract the domain first. Okay, like this. Okay, JX X has taken course in Java for all X JX. Okay, same goes here. But if domain of this course U is all people, S X X is student in the class Java for all X, S X implies the JX. Okay, okay another example. Okay, some student in this class visited Malacca. Okay, how to do that? Akila, not Akila explain. Macam mana nak buat? Okay, 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 tu je. Dia kena ada dua sebab students dengan apa macam ni. Okay, kita lihat let mx denote good, and then we have sx. Okay, x is a student in this class. So you can say for some x s x and x. Clear? Agila? Okay, pastikan it has uh, two predicate mx and sx. Okay, okay class, I think that's all for today.